Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 9, and today we're talking about hypothesis tests for proportion, developing hypothesis and understanding possible conclusions. So this is a new type of hypothesis test. Previously, we've talked about hypothesis tests for the mean in the cases where the population standard deviation is known and then unknown. So you can kind of consider this to be the third part of Chapter 9. So this goes with the assignment, hypothesis test for proportion, developing hypothesis, and understanding possible conclusions. The objectives in this video are to identify the null and alternative hypotheses for an experiment with one population proportion, and to compute the value of the test statistic for a hypothesis test for proportion. To conduct a hypothesis test for an experiment involving one population proportion, P, first determine whether all conditions that are required to conduct a hypothesis test are met. The conditions for this type of test are shown below. Proportion follows a binomial model with two independent outcomes called success and failure. Number two, the data must have values that are selected at random or from a randomized experiment. Number three, the expected number of successes out of n trials, which is n times p, and the expected number of failures, which is n times q or n times 1 minus p, must both be greater than or equal to 5. So remember, these are the same conditions that are needed to use the normal approximation for binomial. Once the conditions are met, the z-test for a proportion P can be used to conduct the hypothesis test. To conduct the hypothesis test, first determine the null hypothesis, denoted H sub 0, like before, and the alternative hypothesis, denoted H sub A. A null hypothesis follows the status quo for the population parameter. So we've said that before, that the null hypothesis is sort of like a status quo. The null hypothesis assumes that the population parameter being a certain value is true unless there is contradicting evidence. So it's kind of like that innocent until proven guilty idea. The null hypothesis is always a statement of strict equality, such as H sub 0 is P equals 0.5. The alternative hypothesis represents the values for the population parameter that occur when the null hypothesis is rejected. So just like before, the symbol in the alternative hypothesis can be less than, greater than, or does not equal. For one, which is basically what this slide is about. For one population proportion, the null hypothesis assumes that the population proportion parameter P is equal to a certain value, P sub 0. All right, so in a specific problem, the value of P sub 0 will be given. The possible null and alternative hypotheses are shown below. So notice that in all three cases, the null hypothesis is that P equals a certain value, and the alternative hypothesis is either P does not equal that value, P is greater than that value, or P is less than that value. All right, so here's an example. Olivia claims that less than 25% of the students at her school buy lunch. To conduct a survey, she randomly selects 211 students at her school, asking each student whether they buy lunch or not. Olivia finds that 35 of the students buy lunch. And all they want to know in this for this hypothesis test met? And if so, what are the null and alternative hypotheses for this hypothesis test? So first we'll verify whether all the conditions have been met. Let P equal the population proportion for the students at Olivia's school who buy lunch. There are two independent outcomes. Either they buy lunch or they don't buy lunch. So the proportion follows a binomial model. It is given that the students were randomly selected from the population of all students at the school. So that was the second requirement. And finally, the expected number of successes, n times p, would be 211 times 0.25, which is 52.75. And the expected number of failures, n times q, would be 211 times 0.75, which is 158.25. So those are both greater than or equal to 5, and all the conditions have been met. Since all the conditions for this hypothesis test have been satisfied, now we'll determine the null and alternative hypotheses. The null hypothesis would claim that P, the population proportion, is equal to 0.25. Since Olivia is testing the claim that less than 25% of the students at her school buy lunch, the alternative hypothesis would be P is less than 0.25. So this will be what we call a left tail test. So here are your null and alternative hypotheses. Next example, a manufacturing company that produces nails requires that fewer than 0.2% of the nails it manufactures be defective. Tom, a quality control manager, collects a random sample of 600 nails from a recent batch and tests each nail, finding that 5 of the nails in the sample are defective. Suppose Tom wants to use this sample to test whether this batch's rate of defective nails is less than 0.2%. Are all of the conditions for this hypothesis test met? And if so, what are the null and alternative hypotheses for this hypothesis test? All right, so first we'll verify whether all the conditions have been met. If P is the population proportion of defective nails, we have 2 independent outcomes, which are either the nail is defective or it's not defective. That makes it binomial. It's given that the nails were randomly selected. And finally, the expected number of successes, n times p, that would be 600 times 0.002, which is only 1.2. And that is less. So this test should not be performed with this sample. In order to make this number be greater than 5, you would have to have a much larger sample. When conducting hypothesis tests involving a single proportion, P sub 0 is the hypothesized population proportion of successes, and P hat is the sample proportion of successes. So the way that we will calculate P hat is by using X divided by N, where X is the number of successes in the sample and N is the sample size. So just really quickly, in the last example, we would calculate P hat by doing 5 divided by 600. In the previous example with the school lunch, it would be, I think, 35 divided by 211. That would give you your sample proportion. So if n times p sub 0 and n times 1 minus p sub 0 are both greater than 5, that means the distribution of the sample can be approximated using a normal distribution. And it says here that the notation p prime is also used by some books instead of p hat. I was just going to write this out for you. It was a little lazy of them to just write the prime symbol and not put the p there. Okay, so this is what we need. P prime. Okay. All right. So let's see. Oops. Setting up the hypotheses is similar to setting up the hypotheses for a single mean. The type of test, left, right, or two-tail, is still determined by examining the alternative hypothesis. The level of significance still needs to be determined. The differences are that we are testing a claim about a population proportion instead of a population mean. So this right here is really the biggest difference between this type of test and a test about a population mean. It uses a completely different test statistic. The test statistic for a one sample hypothesis test for a proportion is calculated using this formula. So we're going to use Z sub 0 for the calculated test statistic, just like we did a few videos ago where we were talking about testing for a mean where the population standard deviation is known. All right, that followed the Z distribution. So the way that we calculate this test statistic is we take p hat, subtract p sub 0, and then divide by the square root of p sub 0 times 1 minus p sub 0 over n. Notice that this whole entire fraction is under the square root. Okay? So when we get to an example, I think we're coming up on one here, you're definitely going to want to have your calculator handy and make sure that you're able to put in this formula correctly. Once the test statistic is calculated, then a decision for the hypothesis test can be made using either a critical value rejection region approach or a p-value approach. And because we're using the Z distribution, really won't require any technology. We'll be able to get everything we need out of table A2. All right, so the national proportion of college students in the United States who live in a dorm is 63%. A recent survey asked 500 randomly selected college students from a certain region in the United States if they live in a dorm. Of those students, 321 responded yes. The researchers behind the survey performed the following hypothesis test. So it looks like a claim has been made that in this region, that percentage is higher. There are more students who live in dorms, which would lead to this alternative hypothesis. The null hypothesis is P, and the significance level is alpha equals 0.01. So they want us to calculate our test statistic. Okay, so first we calculate p hat. P hat is 321 divided by 500, which comes out to 0.642. And that makes our test statistic 0.642 minus 0.63, which is the hypothesized proportion, divided by the square root of 0.63 times 1 minus 0.63 over 500. This whole fraction is under the square root. So grab your calculator and just make sure that you're able to get this same value out of the formula. Okay, so I just checked that one myself and it is correct. Always have to double check with these folks. Sometimes there are mistakes. All right, George flipped a coin 72 times and obtained 33 heads. To determine if these results suggest that the coin is weighted against heads, he performed the following hypothesis test. So if P stands for the proportion of heads, the null hypothesis is that P equals 0.5, which means it's a fair coin. The alternative is that P is less than 0.5. The coin is weighted so that heads come up less than half the time. And alpha equals 0.1. So we will once again calculate the test statistic. First P hat is 33 divided by 72, which is about 0.46. So your test statistic would be 0.46 minus 0.5, and then divide by the square root of 0.5 times 1 minus 0.5 over 72. And that does come out to negative 0.68. I just double checked. So that'll take care of that for now. In the next couple videos, we will talk about the two approaches to doing hypothesis testing about proportions, which are the critical value or rejection region approach and the p-value approach.